What's up, everybody? Welcome back. My name is Mickey Gaminol. I'm with Gaminol Tutors. This is my second video. I have a new slogan. It is confidence breeds competence. So, intro is going to be from here on out. Welcome to Gaminol Tutors. My name is Mickey Gaminol. Here we... no, that doesn't work. Okay. Welcome to Gaminol Tutors, where confidence breeds competence. So the idea here is I'm going to instill confidence, and with that, you guys can get better at math. If you'll recall last time, we went over addition and subtraction. We were playing a card game, and we're going to continue with that. We're going to do multiplication and division today. So, if you remember, positive numbers were all of our black cards, such as spades and clubs. Example right there. And then negative numbers are going to be our red cards, such as hearts and diamonds. Cool? So, to begin, I want to talk about the differences between addition and subtraction versus multiplication and division. So addition and subtraction is one-dimensional. So this can be weight, time, money, whatever variable you want, but the general idea is it's a quantity of one thing, all right? What we're going to go into now with multiplication and division is two-dimensional. So multiplication and division are just like addition and subtraction in that they're opposites, but they're different in that they require two variables, right? Multiplication and division are going to expand upon each other. The idea here being distance over time, which is going to result in speed. So that's two variables, distance times time, and that's going to give you either like a great distance over the time. You'll see different story questions that involve that. But yeah, the two-dimensional is going to be multiplication and division, okay? And if I lost you there, no worries, feel free to shoot me a message and I can explain it a little better. But before we begin, I'm going to start with an addition and subtraction problem, just to make sure everybody's awake. So, card at random here, we have these two. So we're starting with addition, so you're going to add these. It doesn't matter which one comes first. This is the cumulative property of mathematics. So whichever one comes first is fine. Go ahead and add these two numbers together. Sweet, I got a positive and a negative, so that's a plus. Alright, and I'm going to switch up the colors to blue. Alright, so addition, again, like I said, it doesn't matter. I'll even prove it doesn't matter. -5 or -5 plus 8. Alright, now, if you remember, first thing we look at is which number is larger, right? If we were doing Utes versus BYU players, we'd have 8 Utes and 5 BYU players, so these two are going to clash, therefore you have to subtract them, right? You have to minus them out. So they're not going to combine to create some Ute BYU player, no, they're going to cancel each other out. So first you have to ask which team is going to win. In this situation, it's going to be the positive team, which we'll call the Utes. So 8 plus -5, you take your 5 here, 1, 2, 3, 4, 5 shapes, take away 5 from here, 1, 2, 3, 4, 5 shapes, take those away and you have 3 remaining. So you'll get 3. Now was it positive or negative? We agreed that it is positive because this is the larger number and the larger number is positive, so positive 3. Let's go to the second example in addition, -5 plus 8, and this is just proving the cumulative property. Same deal, doesn't matter, positive number still is going to win, so you combine those two numbers and you're still going to get positive 3. Cool? So that one was an easy one. Let's see if we can find one a little more difficult with our subtraction review. I'm going to erase everything. I'm hoping you guys know these rules by now. So, negative number, let's switch it to green, and then find some cards. Alright. So, hopefully I get one positive, good, and one negative. God, that's too easy too. 2 and -1. Alright, positive 2, -1. We're doing a subtraction problem, so it's going to matter which one comes first. Or -1 minus positive 2. Alright, so 2 minus -1 or -1 minus 2. Now the reason it matters in a subtraction problem is, like we did last time, we turn all of our subtraction problems into addition problems. And we'll do the same with multiplication today. But if you'll recall, what we do is we move this minus sign over to the second term, and we're going to get 2 plus 1, which is going to equal positive 3. In this question, there's no negative numbers, so you know the answer is going to be positive. Let's change this one. Negative 1, we change the second term, so it becomes plus negative 2. These two combine because they're both negative numbers. They're both BYU players. So negative 1 and negative 2 creates negative 3. Now, are these two equal? Definitely not, right? Positive 3 and negative 3 are different. If you create a number line, you'll see that 0, negative 3 is over here, positive 3 is over here. They're about as far apart as you can get, right? So 3 and negative 3 are opposite of each other. So cumulative property does not work with subtraction problems, nor does it work with division problems, but it works with addition and multiplication. And we'll see that again later, here in a little bit. So, good news, multiplication and division is super simple. Super simple. Multiplication and division is even easier than addition and subtraction. Multiplication and division works like this. If signs match, then answer is positive. Positive. Cool? Now, anybody have a guess as to what happens if signs don't match? If signs don't match, I don't like that color. I'm just going to write it simpler here. No match, result is negative. Cool? So if signs match, positive. If signs don't match, negative. Other than that, all the rules that you've learned for multiplication and division before introducing integers are going to reign true. All right? Now you just have to change the answer, whether it's positive or negative. All right. So let's start. Hopefully we get another easy one. Otherwise I may have to cheat the deck a little bit and give you an easy one. But to begin, we have, boom, 3 and 6. Cool, this one's super easy, both positive, right? So we're gonna start with multiplication. All right, multiplication, 3 times 6. The reason we have multiplication, again, like I said, this is two-dimensional. So it's actually giving us a shape, believe it or not. If this is 3, and this is 6 across, 2, 1, 2, 3, 4, 5, 6. This is 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. So 6 spaces across. The result is going to be however many squares are in this shape. And that's why it's two-dimensional. It gives you a little bit of a visual representation. We all know 3 times 6 is 18. If you don't know, what the best way I learned is kids really know their 5s pretty well. So 3 times 5, and then you're going to add a 6th 3. That's how you memorize all of your 6 times tables. Is you think of the 5 times tables and then add that 6th term. So 15 plus 3 is going to give you 18. All right. Now these were both positive, so the answer is just going to be a positive 18. Let's say it was 3 times negative 6. What do you think the answer would be? Well, if we recall, and I'll write it over here real quick. Positive. And then I'll write match with a line through it, which means don't match. Negative. Cool. So 3 times negative 6 is going to result in negative 18. And the way you would draw this is a little bit different. So this is 6 positive in this way, and this is 3 positive in that way, and we can expand that to be an x-axis and a y-axis. Now, if I lose you, don't worry, this is just for the advanced kids. The negative 6 is going to be right here. Well, we'll put it on the x-axis for simplicity's sake. Negative 6, so 1, 2, 3, 4, 5, 6. And then negative, and then positive 3, right? So 1, 2, 3. Cool? So this is technically the same amount of space, right? This is still 18 squares, but it's 18 squares to the negative side, all right? And that might be a little bit much for some of the younger kids, but that's the idea as to why if it doesn't match, it results in a negative number, all right? Cool. So hopefully you've kept up thus far. We're going to do 3 more multiplication, and then we'll switch over to division. All right? And we're not doing face cards just yet. So 3 more multiplication, quick shuffle. 1, 2, 3. All right. Multiplication, again, doesn't matter which one you put first. So either one goes first. So go ahead and multiply those two, both positive. Let me make sure I got it. Oh, cool. 1 positive, 1 negative. Multiply those two together. And multiply these two together. Again, doesn't matter. And this is cool because this actually makes a square. And I got time, I can show you guys a quick square. So, 3 times 8. 3 times 8. Now, this one I would do, 8s are kind of tricky. 7s and 8s are a little bit tricky. I mean, you should know your 3 times tables, hopefully, but the truth is we just memorize eventually that this is 24. You can do the 9s times tables and take away one of those 9s, but that's kind of messy. So we'll just keep it as 24 for now. 3 times 8 is 24. 4 times negative 6. Now, these signs don't match, so therefore we're going to go negative. So 4 times negative 6 is negative 24. Wow, same answer. Isn't that crazy? All right, and then 7 times 7. Now these are both negatives. Negative 7 times negative 7 equals 49. Cool? That's a square, so if you can memorize your squares, you're golden. But the interesting thing here is, are these both negative? How do 2 negative signs result in a positive 49? Well, for now we're just going to say they just do. If I were to draw it out, you would see that we would use this quadrant, and it would be 7 across, and 7 across, 7 across, and 7 across. And all these little squares in here would create 49 squares. And they're going to be positive because they're along this axis, which is actually a positive slope, which is calculus side of things. And we don't need to get there just yet, but that's the general idea. So 49 is positive because the signs match. All right. Now let's switch over to division. Now division is what a lot of kids struggle with. And I'm going to introduce fractions on top of it, which makes it possibly even more difficult. But depending on the student, I can usually read them and see if they're keeping up. And then we go from there. So let's start with this. Boom. 8 divided by 2 or 2 divided by 8. Now remember, with division and subtraction, it matters what the second term is. So we're going to do both. 8 divided by 2 and 2 divided by 8. Now, if you're super advanced, you already know that 2 fits into 8 4 times. What you can do is you can draw 8, 2, 3, 4, 5, 6, 7, 8. 8 shapes, and see how many times 2 boxes will fit in. So there's 2, that's 1. There's 2, that's 2. There's 2, that's 3. And there's 2, that's 4. Because these two match, it's going to be a positive 4. But if we were to do it like I said initially, I'll come back to 2 divided by 8 in a second, and switch it into fractions, what we're doing is we're timesing 8. We change it to a multiplication problem, and we move this fraction bar. Now this fraction bar is everywhere. You see it in percentages, you see it in, of course, fractions, and then you see it in like scores, 36 out of 100 or something like that. Now the fraction bar means divided by, always, all right? So even here, in percentage, what it means is divided by 100%, right? So cent means 100, per is going to be that division. 1 per 4, so 1 per every 4 of us is going to get the cake or whatever, or 1/4 of a slice of pizza or something like that. That's where you split something into 4 pieces. Now, coming back, we say times 1/2. So we move that division over to the 2. All right? Now what is half of 8? Well, it's just 4. Too easy, right? Too easy. Now if we were to switch it to 8 divided by 1, or divided by 2, but we change the 2 to a negative, or we change the 8 to a negative, the result is going to be that these two don't match. So 2 fits into 8 -4 times, and 2 fits into -8 -4 times. All right? So that's the idea behind division. Try not to get lost in the weeds there. It's kind of a lot to unpack, and there's a million ways to talk about how division relates to fractions that can just kind of run in circles a lot of the time. But as soon as you get this concept, you're pretty much golden with all of your fractions and all of your algebra stuff. All right, like I said, we would come back to 2 divided by 8. 2 divided by 8. Now, I like to write this one, and we can do it the same way. So we can do 2 times 1/8. And what we do when we multiply fractions, we'll come to that later. But basically, we'll stick with this for now. We'll say top dog gets the house. So what top dog gets the house means is whatever is in front. Another way to write this is 2 divided by 8 is like this. And we say the top dog. Who's the top dog? In this case, it's going to be the 2. All right? Now, what you can do is you can say this guy gets the house. So you put the 2 inside the house. Too easy. And then you put the 8 outside. Now, how many times does 8 fit into 2? Now, everybody knows 8 doesn't fit into 2. If I have 2, and then, like, if I have these 2 here, and I have these 8, is this ever going to fit into that? No way, not evenly, it's too big, right? So what you do is you say 2.0. Now you have 8 goes into 20. How many times does 8 go into 20? Twice, which results in 16. 8 times 2 is 16, subtract equals 4, and then you bring down another 0. Remember, we haven't changed the 2, because 2 is equal to $2 is equal to $2.00, or $2.00 or $2.00. Same idea. So how many times does 8 go into 40? Now again, this is where kids know their 5s. So 8 goes into 40, 5, 10, 15, 20, 25, 30, 35, 40. 8 times. 5 goes into 40 8 times, so we do 0.25. Alright? 0.25 is the same as 1/4. And again, we can go back and reduce this. We divide the same number on top as on bottom, we get 1/4. So the answer is 0.25 or 1/4. Alright? Easier way to explain that, which I'm sure we could all use, is if the signs match, it's positive. If the signs don't match, it's negative. Alright? Let's try one more division problem. And then we'll go back to multiplication, because that's a little more peaceful. So, boom. 2 negatives. 2 times 2. Or, I'm sorry, 2 divided by 2. Cool thing about this one, it doesn't matter which one comes first, because they're both the same number. And it's -2 divided by -2, I'm sorry. So, how many times does 2 fit into 2? How many 2's are going to fit into this guy? Just 1, right? Now, last question. Is it positive or negative? Answer is positive. Because the signs match. They're both negative numbers, so the result, therefore, must be positive. Alright? Good work, guys. Like I say, we're going to go back into multiplication real quick, and then we'll work on wrapping up. Multiplication, this is going to be a fun one. So what I'm going to do this time is we're going to do three numbers. 1, 2, 3. Boom. All right. So go ahead, check that out. Go ahead and start writing it out. See if you can solve it. 10 times 9 times 7. Oh, important part. 10 times -9 times +7. So 10 times negative 9 times positive 7. And just like we did yesterday when we did the addition with 3 variables, or 3 terms, we're going to do the same thing here, 3 terms, alright? 10 times negative 9 is going to be negative 90 times 7. Alright? Now, 9's trick. I'm happy we got one of these questions. The 9's trick is super cool, and you can do it with any 9 times anything other than under 10. So 9 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9 times 7, what you do is you count here, we all have fingers hopefully, and you count over 7. So you count over 1, 2, 3, 4, 5, 6, 7. On this side is going to be our 10 side. We have 60. 1, 2, 3, 4, 5, 6, 60. On this side we have 3. 1, 2, 3, 63. So the answer is 63. Question for you, positive or negative? I hope you guys are saying it's negative. And don't forget, since it's 9D instead of just 9, it's going to be negative 630. Alright? Negative 630. Good work. I was a little bit fast. I'll probably be slowing down over the coming days. It works a lot better when I have a little like face-to-face interaction. But feel free to hit me up if this made sense or if it didn't make sense. If you or your kids need help with any math homework or anything like that, feel free to inbox those, and I'd be happy to take a look at it. Once again, this is Gaminal Tutors, where confidence breeds confidence.